fractions. That's always a good place to begin. We find that in the CSEC, CSEC examinations, we do not always begin with them, but for the most part, we use them as the first problem in our examination papers. Before attempting to solve the problem, let us convert the mixed number to an improper fraction. How do we do that? Before taking a look at how we do that, let us label the different components of a mixed number. We have the whole number, we have the numerator, and we have the denominator. In converting this mixed number into improper fraction, we first say 3 multiplied by 1, which is the denominator multiplied by the whole number. That is equal to 3. Then we add the numerator to it. 3 plus 1 is equal to 4. The numerator of the improper fraction will be 4, and the denominator will be the same thing as it has been from the beginning, 3. Of course, we did not need to do this. Do it for 1 and 1/3 again, because we have 1 and 1/3 here, and we have 1 and 1/3 here. They are the same, so we do not need to repeat or reinvent the wheel. Apart from introducing our improper fractions, let us place the lower set of fractions to the side by replacing the fraction bar with a division sign. Fraction bar, no matter where we have them, here, there, here, and everywhere, the fraction bar is always an indication of the division process. Therefore, if we replace a fraction bar with a division sign, then the expression would be the same. So that we have done right there, replacing this fraction bar with a division sign, and we are enclosing the different parts that we have. The original large numerator, we put that in the first pair of brackets, and the original large denominator, we have that in the second pair of brackets. Let us proceed to add the first set of fractions by making use of a common denominator. The common denominator in this particular case is 6. 3 into 6 is 2, then 2 times 4 is equal to 8. 3 into 6 is 2, 2 times 4 is equal to 8. Then 6 into 6 is 1, then 1 multiplied by 5 is equal to 5. The other fractions in the bracket may be multiplied by finding the product of the numerators and the product of the denominators. We could have reduced them before, but let us leave all reduction of fractions for the end, when we may have other reductions to do. Of course, we have a common factor of 2 here and here, but let's not do any reduction at this point. In the end, we will have to do, or it might be that we may have to do some reduction. So let us leave all reduction for the instant at which we need to do reductions. So 4, 5, 20, 3, 6 is 18. Do the little addition and make use of the fact that dividing by a fraction is equivalent to multiplying by its reciprocal. So 8 plus 5 is 13 over 6, and we will make use of the fact that dividing by a fraction is the same as multiplying by its reciprocal. So do the reciprocal. or invert. Right there. Then we may reduce. 6 into 18 is 3. So the answer is 13 multiplied by 3 over 20. 39 over 20. While adding the fractions, 4 over 3 could have been converted to 8 over 6 by multiplying both numerator and denominator by 2. The value of the fraction would have been the same, but it would have the same denominator as 5 over 6, making addition easier. So instead of using 4 over 3 here, we multiply by 2 here. 4 2's 8, multiplied by 2 here. 3 2 6. So we'll have 8 over 6. The fraction would have been the same. The fraction 8 over 6 is exactly the same in value as 4 over 3, but they will have different appearance. When we have 8 over 6, then the denominators would have been the same, and the addition process would have been easier. The higher purchase price may be found by adding the deposit to the product of the monthly installment and the number of those monthly installments. So we have 12 monthly installments, each of $34.50, and we have a deposit of $90. Therefore, we will add the product of the size of the installment and the number of installments that will be added to the deposit, and the answer is $504. In order to determine the amount that is saved by buying the camera, or could have been saved by buying the camera cash, we will of course subtract the cash price from the higher purchase price, and the cash price is $450, and we have just calculated the higher purchase price. Now we have our currency problem, and I kind of like this one because it has other calculations that are not related to currency conversion that we need to perform in the end. So we have 1 Barbados dollar is equivalent to $1.35 in Eastern Caribbean currency. In that rate, the EC figure is larger. So the EC figure is $1.35, and that is larger than $1. In converting from Barbados to EC, the figure should be larger. That means the relationship is that the figure that we have for the Barbadian currency is $1. The one that we have for the Eastern Caribbean is $1.35. It is larger than this one. If we have a certain amount of money to convert from Barbados to EC, the figure that we should end up with should be larger than the one before. Multiplication will actually achieve this result. So $200 multiplied by 1.35, and the result is $270. Now we need to find Calvin's share as a percentage of the total. Calvin's share is $108. We will write that as a percentage of the total received. 108 divided by 270, that we multiplied by 100, and the result is 40%. to find the Lin's share, we need to subtract Calvin's share and Pat's share from the original amount. The original amount is $270. From that, we need to subtract $108, and we also need to subtract 1/3 of 270. That will demonstrate right here. 270 minus 108 minus 1/3 of 270. And 1/3 of 270 is 90. And when we subtract that, we get $72. And that will be Lin's share. Now, we need to write this as a fraction of the total. So, Lin's share as a fraction of the total. How do we do that? All we need to do is put that over the total of 270. And we need to take a simple look at this fraction reduction. We know that these are numbers that we are familiar with. We know that 9 is a factor of 72, 9, 8, 72, and 9 can go into 27, therefore 9 can go into 270. So we know that 9 is a factor of both of them. Also, both numbers are even numbers. So if 9 is a factor of both of them, and both numbers are even numbers, then we are sure that 18 is a factor of both numbers. So 18 into 72, that will be 4 times, and 18 into 270, that is 15 times. So the fraction is 4 over 15, or 4/15. Algebraic fractions. What do? We cannot perform the operation unless we make use of a common denominator. That is, as usual, the LCM of the denominators. Like in the case of numbers that do not have common factors, the common denominator is their product. Therefore, the common denominator in this particular case will be the product of Q and 3, which will be 3Q. And if we had 4 and 3, the common denominator would have been 4 3s 12. Therefore, we have no difficulty in understanding that if the denominators do not have common factors, the lowest common multiple of both of them will be the product of the two. So we will have the product of Q and 3, and that will be 3Q. Now, Q into 3Q is 3, and 3 5s 15, minus 3 into 3Q is Q, and Q times P is QP. That's all there is to it. The numerator does not have like terms and cannot be simplified. So we do not have like terms here. Cannot be simplified. We leave this numerator as is, divide by 3Q. Here we have a binary operation to the extent that A asterisk B, or we may say A star B, is equal to 2A minus 5B. A asterisk B is 2A minus 5B. What do we do? To cause the binary operator to operate on the numbers, just substitute the numbers in the place of the symbols, or letters in this particular case, in their respective places. So where we see A, we will substitute the value of A. Where we see B, we substitute the value of B, and that is all there is to it. So we have 3 asterisk 2 will be our 3 star 2, 2 3s minus 5 2s. So we will have 6 minus 10, and that will give us negative 4. Then, as soon as we see this, we do not know what to do. What is this? 3 asterisk 2 in bracket and then asterisk 1? No one can do that. We have to make a meal of this problem when we go to the examination. As a matter of fact, this problem is a lot simpler than it looks. We already have the value of 3 star 2, and 3 star 2 is negative 4. So where we have 3 star 2, we will replace that with negative 4. 3 star 2 is negative 4. In order to find 3 asterisk 2 asterisk 1, we may replace 3 asterisk 2 with negative 4. So we will have negative 4 asterisk 1, which will be 2 times negative 4 minus 5 times 1. We have negative 8 minus 5, and that will be negative 13. The first expression to be factorized is a difference of 2 squares. And we know what to do with it. It is required to be factorized at sight. That is how we factorize the difference of 2 square. We just look at the difference of 2 square, recognize that it is a difference of 2 square, recognize each square, and make use of them. We need to determine what was squared to give 4x squared. 4x squared is the square of something. What is that thing that 4x squared is the square of? The answer is 2x, and will occupy the first position in both pairs of brackets. Then we need to determine what was squared in order to give 9. It will occupy the second position. So what was squared to give 9? And the answer is 3. Therefore, we have 2x, 3, 2x, 3. The sign in one bracket needs to be positive and the other negative. The order of the signs does not matter as long as one is positive and the other is negative. Now we have 4 terms, and 4 terms mean quadratic expression. An expression that has 4 terms. We will factorize by grouping. Perform factorization by grouping by taking the terms 2 at a time. These 2. What is the common factor of these 2? The common factor of the first pair is m. Then what do we know? M will cancel m, gives p, and m will cancel m, gives q. So we have p plus q. And in the second case, dealing with, of course, the second pair, the common factor is negative n. Take a factor of negative n, and negative n into negative np. Negative into negative is positive, and then we have negative n into negative nq. Negative into negative is positive, so we have p plus q. Then we go further, taking another common factor that we can see to be what? P plus q. And those will go into the brackets. So we have in one bracket p plus q, and in the other m minus n. And that is all there is to it. In the case of the second pair, we have a negative common factor. On dividing each term by the common factor, we need to consider the signs also. So in dividing, we need to consider the signs. So what do we say? the terms of the second pair are negative. Dividing by a negative common factor will result in two positive terms. So negative into negative is a positive p, negative into negative is a positive q. That's what we mean, considering the signs that we are using. It is not quite often that we see trinomials written as we have on this occasion, but surely we have seen a similar one before, at least a similar one. That means some students, they see this and they do not recognize that it's a trinomial, because apart from the fact that we have 2x squared, we have the middle term is 3xy, and further the final term is y squared. So although it has three terms, they say, no man, we don't know this one. We have never seen this one before. But it is our regular trinomial and may be factorized in a similar fashion. As usual, we will resolve the middle term into its two components. This is done by finding the two numbers which, when multiplied, will give the same result as the product of the two end coefficients. 2 multiplied by 1 is 2. So the two numbers will multiply to give 2, and when we add them, we get the middle coefficient, which is 3. And there is no doubt that we are still at 2 and 2. So the single middle term that we have here will have two components now, 2xy and xy. The two numbers that will multiply to give 2 and add to give 3 is 2 and 1. So 2xy and 1xy, which is still xy. Then we will factorize as usual. The two numbers are 2 and 1. They have replaced the single coefficient of the middle term. A coefficient of 1 does not have to be written, which is this one, does not have to be written. We just put xy. So 2x into 2x squared is x, and the 2x will cancel with the 2x, and we have y. We take a common factor of y for the second pair. Y will cancel with y, and we have x, and y into y squared is y. In the common factor we have x plus y, and the other factor will be 2x plus y, and that is all there is to it. Trinomials like this are in phase 1 practice paper that my students practice in preparation for their examinations. After we obtain the expression that contains 4 terms, the method of factorization is the same as on the previous slide. So after we have resolved this into its two components, arriving at our 4 terms factorized by grouping as before, and we have our factors. And this form of trinomial is by no means difficult, much more impossible. Now, for 3a, we will transpose this formula, making r the subject. In making r the subject of the formula, our first step is to eliminate pi and h from this right hand side. They are being multiplied by r squared, so they are in a multiplication relationship. We will eliminate them by dividing through the entire equation by pi h. By so doing, pi and h will be eliminated from the right hand side, and on the left hand side we have v divided by pi h. Next, we need to eliminate the square. The opposite of square is square root. We will therefore find the square root of the right hand side, because by eliminating this square here, we need to find the square root of both sides. The square root will eliminate the square on the right hand side, and on the left hand side we have the square root of all of v over pi h, and that is equal to r. Appropriately place r on the left hand side. Here we have a quadratic equation that we may solve in any of the three ways. One way is by factorization, another is by completing the square, and another is by making use of the quadratic formula. However, when we can factorize, factorization is usually the more acceptable method. There we have a quadratic equation. The left hand side is a trinomial that we will factorize while solving it. The middle term needs to be written as two terms. Its coefficients will be the two numbers that give a product of 2 times negative 2 and a sum of 3. So which numbers do you know will multiply to give the same thing as when we multiply 2 with negative 2? That will give a negative 4. They multiply to give negative 4, and they add to give 3. So those numbers are 4 and negative 1. They will be the two components of the two middle terms that will replace the single one that we have right here. The common factor here is 2x and x. Then 2x into 4x is 2. Then we do not see a common factor. We will choose one or a negative one to be our common factor. Negative into negative is positive, and negative into negative is positive. The common factor of x plus 2 goes here, and the other factor 2x minus 1 will go there. And that kind of a factorization we are accustomed to. As a matter of fact, we saw one on a recent slide. Now that we have finished factorizing, let us finish up by solving the equation. X is equal to negative 2 and x is equal to a half. On this slide, we will look at some of the processes in solving the quadratic equation under the microscope. There we have 2x squared plus 3x minus 2 is equal to 0. We have two processes. One is the factorization. So let us take a look at the factorization. To find the coefficients of the two middle terms, consider that the trinomial is in the general form of ax squared plus bx plus c is equal to 0. That's the general form. We will factorize that trinomial by resolving the middle term into its two components. And that will be done by saying what are the two numbers that give the same product as a times c. Those two numbers will give the product ac, and when we add them we get b. So what two numbers will multiply to give 2 times negative 2? They will multiply to give negative 4. What two numbers multiply to give negative 4? And when we add them, the result is 3. What are those two numbers? A positive 4 and a negative 1. Those will replace this single middle term. So we have 2x squared plus 4x minus x minus 2 is equal to 0. The factorization will be performed by grouping. The common factor of the first pair is 2x. So 2x is the common factor of the first pair. 2x into 2x squared is x. 2x into 4x is 2. The common factor of the second pair is negative 1. And any number divided by 1 is that same number, but we need to consider the sign. So negative into negative is positive. We will have a positive x, and the negative into negative 2 is positive 2, and the result is equal to 0. The common factor is x plus 2, and the other factor is 2x minus 1. Good. If the product of two numbers is 0, then either one or the other or both are equal to 0. The contents of the brackets are being multiplied and the answer is 0. We will then equate both of them to 0. So this is the premise by which we solve a quadratic equation when we have the factors. These two multiply to give 0. So this one is equal to 0, or this one is equal to 0, or both of them are equal to 0. So we will solve this one, x plus 2 is equal to 0, and we will solve 2x minus 1 is equal to 0. This one is a single step. X plus 2 is equal to 0, x is equal to negative 2. And for the other one, 2x minus 1 is equal to 0. 2x is equal to positive 1. Then we say x is equal to a half by dividing both sides by 2. And our set problem. 15 students passed geography. X of them are in the intersection. The number unique to G will be the rest of them. So we know that 15 students passed geography, and the set of those who passed geography is represented by this green circle. X of them we have in the intersection, hence also in the set of those who passed geography. Therefore, the rest of the 15 will go here, which is 15 minus x. Do not forget those that did not pass any of the subjects. When we are doing set theory, that figure, that number, those elements are the ones that are the easiest to forget. The ones that are in the Venn diagram, but not in any of the sets that we have inside there. So do not forget those that did not pass any of the subjects. The number of them will be placed in the Venn diagram, but not in the sets H and G. There we have them, 6 of them. What do we do next? Write the expression that represents the number, the total number of students in the entire survey, and that will be done by adding all of these, including the 6, of course. So we have 25 minus x, we have 15 minus x, we have the x, and we have the 6. When we put those together, we may do that by adding the numbers. 25 plus 15 is 40, plus 6 is 46. Notice that we have a negative x here, and a negative x, and a plus x. We may just use this one, negative x, to eliminate this positive x, and all that is left is a negative x. So that is 46 minus x. Well, one may imagine the next step. The next step may be just to find the value of x, which is what is usually required. In order to find the value of x, we need to equate the expression in 2 to 35. And 35 is the number of visitors in the entire survey, and then we may solve the problem. So x is equal to 46 minus 35, and x is equal to 11 students. Actual distance is given in kilometers, and the distance on the map is required to be in centimeters. We may convert our units to centimeters now or at the end. Because of the need to divide by 180,000, it is wise, judicious, to convert to centimeters at the beginning. Now, according to what we have for this problem, we have the distance in actuality, and we need to convert to the distance that we will have on the map. Therefore, we will convert, because of the need to convert or to divide by 180,000 in the end, we will multiply by 100,000, converting the distance that we have in kilometers to centimeters. So we will therefore multiply the distance given in kilometers by 100,000, because 100,000 centimeters is equal to 1 kilometer. 11.7 multiplied by 100,000 will give 1,170,000 centimeters. To convert to the distance on the map, we will divide that number by 180,000, and that is equal to 6.5 centimeters. Now we have the distance given as 11.7 kilometers, and we need to determine what distance it represents on the map, taking into consideration that the rate or the scale of the map is given as 1 to 180,000. Some candidates may want to take the two steps in one, because this is not very difficult for us to see that we can just do one thing like that. 11.7 times 100,000, and that we divide by 180,000. That is because we need to convert first, because the distance on the map is given in centimeters. We convert the kilometers to centimeters first, and then we divide by the scale, and we will end up with 6.5 centimeters. Students are sometimes baffled by the scale on a map. Notice that in the representation of the scale of the map, there is no unit. This means that both units are the same. So if we have a ratio and no unit is in the ratio, then we are sure that the two units in the ratio are actually the same. So if we have a ratio of distances and we have 1 to 180,000, that means it will be 1 centimeter to 180,000 centimeters. This means that 1 centimeter on the map is represented by 180,000 centimeters in actual distance. The only conversion to be considered is the conversion from centimeters to kilometer, or vice versa, of the distance calculated. So if we have a distance calculated in centimeters and we need to convert that to kilometers or vice versa, then we'll have to make a conversion. But there is no conversion within the scale that is given for the map. Here we have a triangular prism with cross-section equal to a right-angled triangle. The area of a triangle is given by half base times height. We are required to find the area of the cross-section. The height and base must be perpendicular to each other. That is why we may just say half base times height. In saying half base times height, we are making the assumption that the base and the heights are perpendicular to each other. That is a right angled triangle that we have right there for the cross section. So we are sure that they are perpendicular to each other. The cross section is in the shape of a right angled triangle. We therefore have the sides that are perpendicular to each other and may use them as the base and the height interchangeably. So we may use these two, since they are perpendicular to each other in the triangle, we may use them as base and height because the base and height are required to be perpendicular to each other. Area is equal to a half base times height. Put in half 10.5 14 or half 14 10.5. That turns out to be 73.5 centimeters squared. We have the cross-sectional area that we have just calculated, and the volume is given to us. We are required to calculate the length of the prism that we have right here. Let us write an expression that shows how length and volume are related to each other. So for the volume of a prism, volume is equal to the cross-sectional area multiplied by the length. The volume we know to be 1470 and the area we know to be 73.5. So we will substitute those values in the equation. All that we do not know is the value of L. L may be found, therefore, by dividing 1470 by 73.5. Just by looking, we see that this is 7. 2 7s 14. Also, neglecting the point, we have 35. 2 times 35 is 70. So we are sure that we have some multiple of 2 right there. So divide by 73.5 and the result is 20. So L is equal to 20 centimeters. A prism has a uniform cross-section. This means that if it is to be cut in slices, there's a way to cut it in order that all of the slices will be of equal size. And those slices will be representations of the cross-section. Construction. Lovely. For the most part, when CSEC gives a construction problem, the order in which the information is given may be the same as the order in which each component may be implemented. This one is an exception because all lengths are given before all of the angles. This is not such a bad thing, because in constructing a trapezium, the prudent student will implement the 2 right angles first. One of the right angles is, watch this, BAD, and the other is ADC. Notice that we have the AD here and the AD here. Therefore, the segment AD is a part of both of them and should be drawn first. So we will do that. First, draw the line segment AD is 6 centimeters. Use your ruler, your Cambridge. Go straight ahead and 6 centimeters. We will begin our 90 degrees construct by first extending the line at D. We will say produce the line AD at D. So AD produced. Alright. Place the compass point at D and make a semicircular arc as shown. I particularly like the way that one of my students solved this problem. Lysandra Richards. Right. So Richards was very sure that her two right angles needed to be relative to the side AD that is given or drawn as a horizontal line. So place the compass point at D, and that compass point is that little red circle. Place that compass point at D and make a semicircular arc as shown. Place the compass point at the point of intersection of the line AD and the semicircular arc and make an arc as shown. Intersection of the line AD and the semicircular arc, place your compass point right there, little red circle, and make an arc like so. Then place the compass point at the point of intersection of the semicircular arc and the pale construction line. In construction, we do not imagine that we will draw an arc and not use it, or a construction line and not use it. So there we have it. We have used it. Place the point of the compass at the point of intersection of one of the small arcs and the semicircular arc and make another arc. So we are making use of the semicircular arcs now. Place the compass point right here and make another arc as shown. Then what do we imagine? Since we have done all of this, we will not make it be done in vain. Move the compass point to the point of intersection of the other small arc and the semicircular arc and make another arc as shown. And as I said before, there is no use drawing arcs or construction lines and not using them. We will finally make use of those two arcs by drawing a pale construction line that goes from D through the final pair of arcs. DC, the part of the line that is 5 centimeters in length, will be what we are attempting to draw. DC goes up like that. As a matter of fact, this is not DC. We have just completed the right angle and we need to put the length DC in. DC will be how long? 5 centimeters. So use your ruler, measure 5 centimeters, draw that line to 5 centimeters. Do another 90 degrees construct BAD with the 90 degrees angle at A, the details of which will not be shown, and then finish up by drawing the line AC, which is equal to 8 centimeters. So the other right angle that will be constructed here, we will not go through the details of explaining. We'll just show the construct of it. And I'm sure that we do not need to repeat this construct right here for an understanding of it to be developed. And if we really need to repeat it, then we may rewind the video. So there we have the construct, and that one needs to go up by 8 centimeters. I think that this should look a bit familiar, and I will explain why in a minute. Finish the trapezium by drawing the line BC. So there we have the line BC. Remember that on the previous practice paper, we had the situation where we had the cross section of a prism, and we have a right angle right here and a right angle over here. I was suggesting that it is possible to have something that looks like this. However, the examiners expected us to make use of a rectangle. Now that we have gone through these constructs, we see here that it is not impossible to have two right angles here, and yet still we do not have two right angles here. We see that that is a possibility by even making the construction of this trapezium that we have right here. So on the previous practice paper, the figure that was given to us may as well be a trapezium like the one that we have here. It could have been conclusively a rectangle, but sufficient information was not given for us to come to that conclusion. Now we need to do some measurement. Let us measure BC. Measure the distance BC, and that is 7 centimeters. There is a slight difference between the length of BC obtained on this paper and on the computer. There is always an exact value that the examiners are working with, but they expect that there will be slight variations in the answers obtained, even if the correct approach is taken in constructing the figure. In addition to that, the difficulty in creating a computer representation causes the process to be more prone to error, but not necessarily, because as we saw on the previous practice paper, the figure that was obtained on the computer was more accurate than the one that was obtained on paper. But it is true, as a matter of fact, that the one that we obtained from the computer is more prone to error. There is an obvious difference in the size between the triangle and its image. We therefore begin by saying that we have a size transformation. We know that there's a transformation here between this triangle JKL and its image J prime K prime L prime. We need to determine or describe fully the transformation from this original triangle to its image. There's an obvious difference in size. When we have a difference in size, we have a size transformation. That's not difficult. So, because of the difference in size, we know that there exists a size transformation. So we will begin by saying we have a size transformation. The image is larger. We may call the transformation an enlargement. In an enlargement, the center, the image, and object are all collinear. If we draw lines that go from points to their images, they should all pass through the center. The line LL prime is already there. Let us highlight that line and also show the line K prime. Okay, in describing fully a size transformation, we need, of course, to say that it's a size transformation. We have done that already. We need to say that it is a size transformation. We need to give the center of the transformation, and we need to give the scale factor of the transformation. Alright. Now, in finding the center, we know that in every single case, the line that goes from the point to its image will pass through the center of enlargement. Therefore, this line that we have right here passes through the center of enlargement. It goes from L to L prime. The one that goes from K prime to K also passes through the center. Therefore, the point of intersection of those two lines will be the center of enlargement. The lines intersect at the center of enlargement, which is that point 2, -1. That is our center of enlargement. The center of enlargement is 2, -1. To finish up with the components that will allow us to give a full description of the transformation, let us work out the scale factor. What do we have there? The distance between L and the center of enlargement is 5 units. Then we will make use of the distance between L prime and the center of enlargement, and that distance is actually 10 units. Let's take a look. Start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And down here we have 1, 2, 3, 4, 5. Notice that we are counting each time from the point that is given to us as the center of enlargement. And the distances are 5 units and 10 units respectively. What is the significance of taking note of those distances? The distance between the image and the center is equal to the distance between the point and the center multiplied by the scale factor. To find the scale factor, we therefore divide the distance between the image and the center by the distance between the point and the center. Now, let us take a look. If we are attempting to find or to locate the image of the point L, which is L prime, we have the scale factor, say, and we have the original point. We will measure the distance from the point to the center. Then we multiply that distance by the scale factor, and that will be the distance from the center to the image of that point. So take the distance between the point and the center, multiply that by the scale factor, and we get the distance between the center of enlargement and the image of the point. Therefore, if we divide this distance by this one, we will get the scale factor. Scale factor is 10 divided by 5, and that is equal to 2, but not really. We may say not quite. What was calculated on the previous slide is the size of the scale factor. The object and its image are on opposite sides of the center of enlargement. This makes the scale factor negative. Notice that we have the center of enlargement here. Below it we have the original point. Above it we have the image. Because they are on opposite sides of the center of enlargement, the scale factor is negative, and we are sure of that. If they were on the same side of the center of enlargement, then the scale factor would have been positive. So the scale factor in this particular case is a -2. The transformation is therefore an enlargement with scale factor -2 that is centered at the point 2, -1. before we can reflect in the line x is equal to 3, we need to identify that line. The line x is equal to 3 is a vertical line that crosses the x-axis at 3. Need to reflect this triangle in the line x is equal to 3. Before we can do that, we need to be able to identify that line x is equal to 3, and we may proceed to reflect that triangle in that line. There are two properties between a point and its image. The first one is that the line joining a point to its image is perpendicular to the mirror line. The mirror line is vertical. The line that joins the points to their images must be perpendicular to the mirror line, must be horizontal. So the line is vertical, the mirror line is vertical. The line that goes from L prime to its image is a horizontal line. The same is true for J prime and K prime. That is the first one. The line that joins a point to its image is perpendicular to the mirror line. The mirror line is vertical. We may therefore make use of the horizontal lines of the grid because horizontal and vertical are perpendicular to each other. This is the mirror line. The line that goes from L to its image is perpendicular to it. The line that goes from J to its image is perpendicular to it. It is a vertical line. We need horizontal lines, but we have them there already. The grid provides us with horizontal lines. Next, a point and its image are equal distance from the mirror line. Let us show the distance between each point and the mirror line and use that distance to locate the distance of its image on the opposite side of the mirror line. The distance between L prime and L double prime will be the same from the mirror line, and L and L prime are on a line that is perpendicular to the mirror line. Let us begin with J. J is 3 units from the mirror line. Its image is also 3 units from the mirror line, but on the opposite side, like so. K is 7 units from the mirror line. Its image is also 7 units from the mirror line, but on the opposite side, like so. And L is 1 unit from the mirror line. Its image is 1 unit from the mirror line also, but on the opposite side. There you will find L double prime. Complete the triangle. Right. Notice that this line joining L prime to L double prime is perpendicular to the mirror line, and this one that joins J prime to J double prime is perpendicular to the mirror line. That is a property of reflection. When you are on the grid, do not use a ruler to measure distances. Make use of the simplicity afforded by the grid. My students usually learn the hard way on plain paper. When they get to the grid, life is a lot easier. So do not go and start to count or use your ruler to measure 1 centimeter, then you put over here 1 centimeter. Just use the distance that you have here and repeat it on the other side, because I'm sure that you can just repeat a single unit on the other side of the mirror line. In order to find the distance AC, we first need to find the angle ABC. A to B is west, and the bearing of C from B is 40 degrees. ABC is therefore the rest of 90 degrees. We need to find the distance AC, and we will be making use of the cosine rule, along with the fact that if we have two sides of a triangle and the angle that the two sides form, we may be able to find the other side, which is the side opposite to the known angle. But as yet, we do not know the value of this angle. However, it is not difficult for us to determine, because here we have, what here? 40 degrees. And we have our north line. And we are sure that A is east of B. Therefore, this angle is 90 degrees. This angle, the rest of 90 degrees. So the entire big angle is 90 degrees. This one has to be 50 degrees. So 90 minus 40. 90 minus 40 is equal to 50 degrees. There we have it. We have two sides of a triangle and the angle that they form. We may use the cosine rule in finding the other side, which is AC. Now, as we said before, we have the application of the cosine rule, in which we are finding, as a matter of fact, we have two sides of a triangle right here and the angle that the two sides form. And we are using that version of the cosine rule in order to determine the side that is opposite to the angle. So here we have it. AC squared is equal to what? 45 squared plus 32 squared minus 2 times 45 times 32 cosine of 50. In this step, we square 45, we square 32, and we do all of this multiplication in one step. AC squared is equal to 1198, so 1198, and that we will find the square root of in order to find AC to be 34.6 kilometers. Right there. In order to find the bearing of C from A, what do we mean by the bearing of C from A? The bearing of C, if we are viewing that point C from A, so the bearing must be at A, the angle will be at A, and we have to have a north line at A. In order to find the bearing of C from A, we need to make use of the angle that is internal to the triangle at A. We have this side opposite to it, and we have a side and an angle that are opposite to each other. We may therefore use the sine rule. We may use the sine rule because we have 50 degrees, and opposite to it we have 34.6. We have these that are known. This angle is the one that we need to find, because we cannot find any other angle at A. The only angle that we can find immediately at A has to be one that is internal to that triangle that we have right there. So we have angle and opposite side. We need to find angle, and we have the opposite side. We may make use of the sine rule, that is always making use of angle and opposite side. So we have sine A over 45. Sine A over 45 is equal to sine 50 over 34.6. And by transposition, we have sine A is equal to 45 sine 50 over 34.6. That turns out to be 0.9963. If we have the sine and we need to find the angle, we make use of what is called the sine inverse. The sine inverse is opposite of taking the sine, or the inverse of taking sine. So we will find the sine inverse. Usually we use our calculator to do it. We hardly ever use table booklets these days. So we'll use our scientific calculator, and presto, A is equal to sine inverse of that angle, which is 85 degrees. And we'll place that 85 degrees right there. Now that we have found the angle that is internal to the triangle, now we may find the bearing. Let us show the angle that represents the bearing of C from A. Do not forget that if we are talking about the bearing of C from A, what must follow directly? 1. The angle has to be at A. And 2. Bearing is measured in a clockwise direction beginning at north. So that is our angle that represents the bearing. As we can see, if this is 85, we have 90, 90, 90, and this is 85. It will be 5 degrees less than a total revolution of 360 degrees. That will be 355 degrees. But on this particular slide, we are saying that what we have here is 90, 180, 270, and this is in excess of 270 degrees by 85 degrees. The angle is 85 degrees beyond the west. So 270 plus 85 is equal to 355 degrees. On paper, the cos rule was used as a confirmation of the accuracy of the answer, because the sine rule gave an answer close to 90 degrees. In such a case, or when we are not sure whether the angle is obtuse or not, it is best to use the cosine rule, because the sine rule will not give an obtuse answer. I did not use the cosine rule at first because I erroneously estimated that the angle would have been comfortably within the acute region. What I'm saying is that you should not use the sine rule if you are not sure whether or not the angle is acute. You should use the cosine rule. In the event that the angle is obtuse, when you use the sine rule to work it out, you will not get an answer that is obtuse. You will get an acute value. So if you are not 100% sure that the angle is acute, do not use the sine rule. So on calculating the angle, I realized that it is 85 degrees. 85 degrees is so close to 90 degrees that I had to recheck it by using the cosine rule. And I'm saying that I used the sine rule initially because I estimated erroneously that the angle would have been comfortably within the acute region. Now we are taking a look at the equation of a straight line. The equation of a straight line has the general form y is equal to mx plus c. Making use of the general form in determining the equation of the straight line that passes through negative 5, 3 and has gradient 2, 5, we will substitute 3 for x, negative 5 for y, and 2 over 5 for the gradient. And the gradient is given as m. This is the general form of the equation of a straight line. We were told that the line passes through negative 5, 3 and has gradient 2 over 5. Therefore, y is 3, x is negative 5, and the gradient is 2 over 5. We will substitute those right there. Lovely. Solve the equation for c. need to find the value of the constant c. Y is equal to mx plus c. C is the only unknown. We need to know it in order to determine the equation of the straight line. Get -5 ready for addition or subtraction with a fraction whose denominator is 5. What will we do? Multiply -5 by 5 and place the result over 5. We will discuss that a little bit more. Now, we know that we will have 2, 3, 6, 6 over 5 on the right hand side. On the left hand side we have -5. We have a fraction whose denominator is 5. If we could have a fraction on the left hand side whose denominator is 5 also, it would not be too difficult to combine the two. In order to make this into a fraction whose denominator is 5, we multiply this -5 by 5 and put the result over 5. So what we have here is -25 over 5. But if we divide it, we will get what? -5. Now this is another way of writing the -5 and writing it in such a way that it can be easily combined with the fraction whose denominator is 5. So this 6 over 5 is transposed to the left hand side. -25 over 5 minus 6 over 5, all of -31 over 5. Why? Because when we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. Y is equal to mx plus c. Now we have the value of the gradient that we know to be 2 over 5, and now we have the value of c, -31 over 5. Those we will substitute into the equation. So finally, write the equation of the straight line in the form y is equal to mx plus c by substituting m, 2 over 5 as before, and c, -31 over 5. -25 over 5 is still -5 as discussed before. The only difference is that it is written in a form that makes addition or subtraction with a fraction that has a denominator of 5 very straightforward. The step is 1. Multiply the denominator of a fraction. So we'll take this, multiply by the denominator of a fraction, and 2. Place the result over the denominator of a fraction. We need to show that a line is parallel to the line BC that we have just discovered the equation for. Recall the line BC. We need to show that a line is parallel to the line BC whose equation we have just found. So recall the line BC. That is the line BC. We need to show now that another line is parallel to it. We need to determine if the line with the following equation is parallel to BC. 2x minus 5y is equal to 1. Is that line parallel to BC? The equation of a straight line has a general form that we have right there and that we are using for about the third time today. The line BC is in that general form. In that general form, the gradient of the line is the coefficient of x. So the gradient is exactly the coefficient of x when the equation of a line is in that general form. If it is not in that general form, we cannot make that conclusion. Now we have the line 2x minus 5y is equal to 1. Take the equation of that new line and write it in that general form. So take the equation of that new line that we have right here. 2x minus 5y is equal to 1. Take the equation of that new line and write that one in the general form. Our first step in transposition is to transpose negative 5 to the right and 1 to the left. So we have this 1 and negative 1 right there, and this negative 5y, a positive 5y. Alright. We could have transposed it another way and we would have arrived at the correct answer, providing that the subsequent steps are correct. But my suggestion is always, if you can immediately get the proposed subject of the formula to be positive, and in that general form the proposed subject of the formula is y, therefore we get it to be positive. So divide through by 5. That is the next step. Divide through by 5. What do we know? 2x minus 1 over 5 is equal to y. And we divide each term by 5. We get 2x over 5 and negative 1 over 5. And that is equal to y. Turn the beta around. We have y is equal to 2 over 5x minus 1/5. And that is the equation of the new line written in the general form. What do we know now? In the new equation, the coefficient of x is the same as in the previous one. They therefore have the same gradient. When lines have the same gradient, they are parallel. This proves that the new line is parallel to the previous one. In concluding, we may say that in order to determine if lines are parallel, our best shot is to write them, both of them, in the general form. If we write them in the general form and the gradients are the same, then they are parallel. And what do we know to be the gradient? We can identify the gradient as the coefficient of x in each case. Now for functions. We have g of x is 4x minus 5. To find g of 3, substitute 3 in place of x in the function g. We need to determine g of 3. Where we see x, we put 3. G of 3 is 4 times 3 minus 5. And 4 times 3 is 12. Minus 5 is 7. That's all there is to it. G of x again is 4x minus 5. But what do we need to do on this occasion? We need to find f of g of 2. We need to realize that f is operating on g of 2. See? F of g of 2. F is operating on g of 2. Because of this, we need to find g of 2 first. Then cause f to operate on the result. So find g of 2 by substituting 2 in the function g. So where we see x, we put 2. G of 2, 4 times 2 minus 5. 4 2's 8 minus 5 is 3. Now we have found g of 2. F is operating on g of 2. So let us cause f to operate on g of 2, and g of 2 is 3. Let f operate on 3. So f of 3 is equal to 2 times 3 minus 1 over 3 plus 3. Substitute the values obtained for g of 2, which is 3, into the function f. So 2 3's minus 1 over 3 plus 3. 5 over 6. 2 3 6 minus 1 is 5. So that is 5 over 6. What do you know? We are required as usual to find the inverse of the particular function. One method of finding the inverse of a function is to take an expression of the function and replace x with f of x and f of x with x. So where we have f of x, we replace that with x, and where we have x, we replace that with f of x here and there. We will then transpose the function, making f the subject. However, on transposition, the resulting expression will be f inverse. It is therefore more appropriate to replace x with f inverse, because we are actually finding the inverse of the function. When we are through, the resulting function will be the inverse of the function. Therefore, it is more appropriate to put f inverse rather than f. This is our term that we use for eliminating the denominator. Flatten the equation by multiplying by the denominator on the left hand side. So flatten that equation, and that is the result. So we have, take this x that we have right here, and that is to be multiplied by f inverse of x and also by 3. We may place them in brackets, and then at the end we expand the brackets. We did not have to use the brackets because we are sure that if we are multiplying by the denominator, we need to multiply by each term that is in the denominator. So x, f inverse x, and x times 3, which is 3x. What do we do next? Gather the occurrences of f inverse on one side. Gather the occurrence of f inverse on one side, preferably the right hand side. Now we have two occurrences of f inverse. That is what we are attempting to make the subject of the formula. They are on opposite sides of the equation. Therefore, we will transpose them to the same side, preferably the right hand side. So whereas we have 2f inverse x here and x f inverse x, we will have a minus x f inverse x, and we will have this minus 1 transposed to a positive 1. Arrive at one occurrence of f inverse x by factorization. So we factorize taking f inverse x as a common factor, and we have left 2 minus x. Finish up eliminating 2 minus x by division, because this f inverse x that we have here is being multiplied by the bracket that we have right here, or the contents of the brackets. Therefore, we will divide by the contents of the bracket on the left hand side. Appropriately place f inverse on the left hand side, and that is the result. In using transpositional formula to arrive at the inverse of a function, sometimes instructors will say replace f of x with x and x with y, and then in the end, when you find y, you would have found f inverse x. Right? They are just doing that to make the expression less cumbersome. It is always more appropriate to have your occurrences of f inverse x. But if it is too cumbersome, use y. And students may go through this and say that this is such an ordeal. So On the other slide, we will take a look at another method of finding the inverse when a function is given in a form similar to the one that we have right here. So there you have your function, and we will try to find its inverse in a simpler way. We'll make use of what I call the inverse of a matrix method in finding the inverse of the function. First, take the coefficients that are in the function and write them as the coefficients of a 2 by 2 matrix. So 2, -1, 1, 3. How easy so far. Take the same approach as in finding the adjoint of the matrix when we are about to find its inverse. The members of the leading diagonal will exchange places. Exchange places with the members of the leading diagonal, like so. And what will happen to the elements of the subordinate diagonal? As usual, change the signs of the members of the subordinate diagonal. Those. And what do we have? 3, 1, -1, 2. And then those will be the coefficients. Use the elements of the resulting matrix as the coefficients in the new function. So f inverse of x is equal to 3x plus 1 over -x plus 2. How nice and simple. The order in which the terms in the denominator is written does not affect the accuracy of the answer. However, it is more appropriate to write the positive 1 first, and that we have done on the previous slide when we divided by the final common factor. There we have it. It is when I was working on Richard James Mathematics Resources that I discovered that if we are attempting to find the inverse of a function that is given in the present form, using the adjoint of a 2 by 2 matrix in finding its inverse will work 100% of the times. And therefore, I'm introducing it to my CSEC CSEC students that they may be able to find the inverse of a function that is given in this form. They may be able to find it in a few short steps. We need to complete the table with cumulative frequency, and also the lower and upper limits of the time that is given in minutes. As we go down, we realize that the lower limits are in a sequence that increases by 5. The upper limits are in a similar sequence. The values of the lower and upper limits that we will use must cause a continuation of the sequence. So we have a sequence. Whatever we use here must cause a continuation of the sequence. 10, 15, 20. 6 plus 5, 11. 11 plus 5 is 16. That's not difficult. In accumulating the frequency, the missing number in the frequency column is that value that will be added to 11, and the result is 20. Let us call that value n. So n plus 11 is equal to 20. N is equal to 9. No problem? See the solution of that simple linear equation? Also, the number that is missing from the cumulative frequency column is the result of adding 20 to 4. So 20 plus 4 is 24. No, we did not have to use the tally at all. We have completed the table without making use of the raw data. Maybe it was given to us as a decoy. On a more positive note, it was probably given to us for us to confirm the accuracy of the answers that we got. Let us do that on the next slide. Tally. One very efficient way of organizing a frequency table from raw data is to tally values in their respective classes. 6 to 10. 22 21 to 25, 16, 16 to 20, 13, 11 to 15, 22, 21 to 25, 26, 26 to 30, 18, where do we put that? 16 to 20, 22, 21 to 25, 28, 26 to 30, 11, 11 to 15, and so on and so forth. We will always be placing those numbers in their respective slots. A fifth item is represented by a diagonal stroke that completes the group of 5. Like we have it right there. Every group of 5 is completed with a diagonal stroke like that. 4, and then the fifth one is diagonal. And we will finish up our table in a few seconds by tallying the rest of the results. You cannot just sit by and allow them to tally in the way that I'm doing here. You will have to do them yourselves. The result confirms the accuracy of the values of the frequency. See? 2, 4, 5, 9, 4, and 1. So we are sure that all of the values are accurate. And those that were calculated were accurately calculated. Next, we will draw a cumulative frequency curve to represent the data. The cumulative frequency curve is drawn by plotting the cumulative frequency against the upper class boundaries of the class intervals. The upper boundaries are 0.5 of a unit greater than their associated limits. What are the limits? Upper limits? 10, 15, 20, 25, 30, 35. So 1/2 of a unit greater, 10.5, 15.5, 20.5, and so on. In drawing the cumulative frequency curve, let us plot cumulative frequency against upper class boundaries. 10.5, 2. Notice that this seems to be exactly on 10, but that's the difficulty we have with the digitization of the screen. It is difficult to get it exactly the way that we want it all the time. Let us see if this is a little bit better. 15.56. Yes, a little bit above 15 and up to 6. 20.511. A little bit above 20 up to 11. 25.5, 20. Yes, a little bit more than 25 and up to exactly 20. 30.5 will go up to 24, 30.5 and then go up to 24, and finally 35.5 and go up to 25. What do we do next? Draw the curve? We may, but it would not be the complete curve. The frequency curve cannot be left above the horizontal axis. It therefore needs to touch the axis where the upper boundary of the class previous to the first would have been. How do we know where it will touch the axis? If we follow the sequence down 20.5, 15.5, 10.5, then the next one is 5.5, since we are going down by 5 units each time. The curve will therefore touch the horizontal axis at 5.5, right there. Now that we have all of our points, including the position where the curve will touch the horizontal axis, let us finish up by drawing a smooth curve through all of the points. When you are drawing a cumulative frequency curve or frequency polygon, do not leave the diagram hanging in the air. Make sure you anchor it on the ground by using the upper boundary, in this particular case, of where the upper boundary of the previous class would have been, and you can follow the sequence down in order to determine that. There we have our very smooth cumulative frequency curve. We need to determine the median, and the median is the middle entry. The median is the middle score and is associated with half of the total cumulative frequency. On this occasion, the total cumulative frequency is small, which is 25. A half of 25 is 12 and a half. The median is associated with a cumulative frequency of 12 and a half. The middle entry should actually be the 13th one, but because the graph is a continuous representation, 12 and a half may be accurately shown on it. So we are taking advantage of the fact that we have a continuous representation rather than a discrete one. Because if we had a discrete one, like we have some single items placed on the ground, then we could just be able to identify the middle one, and the middle one would be, say, the 13th in this particular case, or the 50th entry. However, we are dealing with continuous data, and the continuity in this curve will cause a cumulative frequency of 12.5 not to be an impossible value. So let us make use of that 12.5. So draw a horizontal line from 12 and a half on the cumulative frequency axis to meet the curve. So in finding the median, we go half of the total cumulative frequency, then after half of the total cumulative frequency, we go across where that is 12.5, meet the curve, and then what do we do? Where the line meets the curve, draw a vertical line to meet the horizontal axis. That is it. Where the vertical line meets the time axis, we find the value of the median time. So the median time will be where it meets. So we start off with half of the total cumulative frequency, go straight across and meet the curve, then we go straight down, and then that value is the median, 22 minutes. In order to find the number of students who waited for less than 24 minutes, we will first go to 24 minutes on the time axis and draw a vertical line to meet the curve. So find the number of students who waited for less than 24 minutes. So 24 minutes will be associated with a number of students that we will determine by considering the associated value on the cumulative frequency axis. The number of students will be on the cumulative frequency axis. We go to 24, then we go across. When we go across, what do we get? Next, after going up to meet the curve, we go across from the point of intersection of the curve and the vertical line, and we take note of where it meets the cumulative frequency axis. Since we are talking about time that is less than 24 minutes, the region of interest will be from 0 to 17.5. The region of interest is here. Those who waited for less than, that means when we go up and we go across, since we are talking about less than, we are interested in this region that is here, the region that is below. So this is the region that we have here below, and that goes from 0 to 17.5. As indicated on the axis, we have 17.5 students. Since we cannot have a fraction of a student we will write down 18 students. 18 students will wait for a time that is less than 24 minutes. The probability that a student waited for less than 24 minutes is equal to the number that waited for less than 24 minutes, and we discovered that to be 18, and that we will divide by the total number of students, which is 25. So we have 18 over 25. So those students waited for less than 24 minutes, 18 students, and the probability associated with that will be 18 divided by the total number of students, which is 25, and that is all there is to it.